You got, for each of the A, B, and C, you got 4 spinners. And so 3 times 4. So what is 3 times 4? You can look at it like this. You don't always have to have the tree. As a matter of fact, sometimes most of the time you're not going to have a tree because it's just going to be too many of them. But that's where you get your 12 outcomes from. Okay. All right. Next question. How many outcomes involve landing on a C and an odd number? So here's A's, here's B's, and here's C's. And then right here, or the odd number. So how many is that?
2.
Good, 2. So this hopefully makes a little bit more sense than the one I accidentally gave you. Okay.
So just come out of the one that you gave us and just leave it as is because I didn't complete it.
Yeah, don't worry about it. I'll take care of it. I'm going to give you
Okay.
I'll put 100 on that for everybody that attempted it that was here. Because I mean to give you something easy, believe me. I wasn't making to give you something like that. But you'll have that later once we cover that. All right. So y'all see that? 2 of them. It says landing on C and that's the key word here, and an odd number. Okay. What's the next one? How many outcomes involve landing on a number other than 4? Other than 4. All right. So here's the 4s. Let's just take them out. There's the ones that are 4. So how many is that are left over?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Right? All those are other than 4, correct? Numbers other than 4. So that is, what did we say that was? 9? 1, 2, 3, 4, 5, 6. Yep, 9. Okay, questions about that? Y'all got that? We got plenty of time.
Yeah.
There's only 4 questions. All right. So let's go to number 2. All right. So Philippe is studying the growth of a particular type of plant. He is testing the effects of 4 growth factors: lighting, age, temperature, and humidity. Now, to kind of make this start off easy, how many lighting levels are there?
4.
4.
Good. 4. How many ages we dealing with?
5.
5.
Okay. And then we got how many temperatures? 1.
5.
5. And then 3 humidity levels, correct?
Yes.
All right. So he wants to find a number of ways of combining one level from each of the growth factors. So how many ways are there? Or I wrote those numbers down for a reason, because we're going to go 4 times 5, 5 times 3. All right. And what do we get with that? Let's see. There's a little calculator in here. Four times 5 times 3 times 3 is equal to 180. All right. So there's 180 different ways when we combine all of these 4 growth factors to be considered. Does that make sense? Anybody got any questions? Like I said, we got plenty of time. That's essentially what we call the counting principle. Sometimes it's called the multiplication property because you're multiplying. So all right, let's look at number 3. All right, so we're given a couple of expressions to evaluate. We got both the accommodation and then we have a permutation. Now, one of the things that they've done on here is they don't have it on this calculator for this problem because they want you to do it another way. So you can use your TI, or I'm going to just do it by hand. All right. So here's the permutations formula. I'll tell you what, I'm going to type it out. Looks too crummy. So that's n factorial. Okay.
Mr.
So
Cruz,
what's up?
my evaluation 3 don't look like that.
Yeah, I'm so I told mentioned at the beginning is when I opened it up to go through it, I
Mm-hmm.
had numbered it wrong. So that'll be the one for next week. So I'm going to give everybody full credit for that one. So if you did it.
Oh, because I was about to say the same thing. Mine has 7 questions
I was about to
and
do
none
that,
of
Yeah,
but I
these
saw,
are.
that's
yeah,
why I said is. So I'm just going over this because really it's just a rehash of the stuff that we did last before the exam.
okay.
All right. So let's do this one first since I got the permutations up there. And the permutation is the easier one. So this is 11 factorial up here. And down here. So then what we got, 11 factorial, and then this is 6 factorial, right? All right. Now, at this point, we could do it manually, or at this, or I can just use the calculator to do this part. The thing that's missing for this particular problem is it doesn't have the formula on it, but we can still do that. They took out the factorial too. So I'll just keep on doing it like this. All right. So up at the top, and I'm going to stop at the one down at the bottom because 11 5 minus 5 was a 6. And so down here is the 6 factorial. And then we're going to take those out. And so what's left over, we can do with the calculator. So up at the top, so these are ones now. So up at the top, all we got left is 11 times 10. Well, so then that says 55,400. All right. Now the combinations is a little bit harder because it's got an extra value down at the bottom. So so let's see, we're going to put so this is going to be Up at the top, we're going to have the 9 factorial. The big one always goes up at the top. And then we're going to have an extra 5 factorial there. And then this is 9. I'm just going to have to type it.
Mr.
Mm-hmm.
That ain't what I had on my evaluation test.
Yeah, where you been at? I already explained that. Don't worry about it.
Like I got a flat 0 because we never went over the information.
That's what I said. You weren't here when I went over it. I done told you all about that. Don't worry about it. This is just a rehash of what we did last week. All right.
All right, I was taking this quiz. That's okay.
Don't worry about it.
All right.
So down here, 5 factorial. And then this 9 minus 5 is the 4 factorial. Okay. So again, I'm going to use the full method here. If you got your TI calculator, you can use it to do this, but I can't show you the TI. I don't have an electronic one to cast. So up here.
Anybody else on this one? Anybody else on this bus?
So down here, 5 factorial, 4 factorial. So we're just going to take them out. So this is going to be equal to, and then we're going to have in the numerator, so ours up at the top. Oops, I forgot the 8. And now at the denominator, we got 4 times 3
12
times 2
24.
times 1. So we can take these out any way we like. 6 is right here. 4 goes into 8 twice. So what we're left with is then, because everything down here is now is 1. So this is 9 times 2 times 7. And what is that? So this is 126.
Yep.
So doing it by hand takes a little bit longer, but if you got that TI calculator, make short work of that. Any questions about that?
I can do it by hand, like, but the TI calculator, I really don't understand how to put it in because it don't have that symbol like it has on Alex.
Yeah, you do. It's just under the PRB. Look.
So you put your number in, then you hit the PRB and put your other number?
Yeah. Okay. Put in your big number, put in PRB. And then you put in your, and then you hit your key. If it's permutations, it's automatically on there. Let's see if I can find it for you to show you. It should always be on the Alex calculator. This is the one time it's not on there, and that's when you are they're wanting you to do it by hand. So here it is. So pay attention on this, because what there's a PRB. So you put in your big number first. First thing you're going to do on your calculator is you're going to enter in how many years left. So put in the big number. And it defaults to the PRB. So if you're doing PRB, you just hit enter. Or you hit equal. And then you put in your small number.
All right. Thank you.
So the combinations, then you're going to have to scroll over one. She'll do that one next. Well, I guess you won't, but anyway, let me just show you. See it right there? Oop. So to get to that one, you press the key, the arrow key here, the right arrow.
Okay.
First, and after you put in your big number, you put PRB, go over here with the arrow to get to that one time, and then you hit equal, and then put in your small number.
Gotcha.
All right. So let's go back over here. Finish out this last one. All right. So the last one, it's just very much, just very much.
And you can't even do that. That's like fucking every blue moon.
This one is very much just finding out which one you're using. So let me ask you here. It says a committee consists of 15 people. From a committee, a president, vice president, secretary, treasurer are to be chosen. In how many ways can these 4 offices be filled? Assume that a committee member can hold at most one of these offices. So what do you think that's asking for? You only got 2 numbers.
The permutation, 15 subtracted from 4.
Permutations. Why is it permutations, Felicia?
Permutation.
Why is it permutations? What tips you off about that?
Consist make it as relevant information. No.
What was that?
Well, when it say a certain committee consists of 15 people, so that's important information. That's irrelevant information. So.
Okay, yeah, but here's the thing is, the thing that tells us the permutation is because they're ordered. The president, vice president, secretary, and treasurer, those offices are, they have different weights. In other words, one is the head of the other. It's like first, second, third, and fourth place.
Okay.
So for this.
So it's distinct. That's what you're saying. Information. Gotcha. Implementation.
So now they're back here. So 15. And we're choosing 4. And we got the P because they're ordered.
Order matters. Okay.
Yeah, order matters. So 32,760 different ways that we could fill these offices from 15 people if we're picking 4 of them. Okay. All right. So from the 13 albums released by a musician, the recording company wishes to release 9 in a box set. In how many different ways can this happen? First of all, let me write up here. This was permutations. And then down here, which one is this? Is this permutations or combinations? That you got to keep in mind. They don't always give you one of each. Sometimes they'll give you 2 of the same type. Sometimes it will be one of each. What do you think this one is? Is there anything up here about the order of the songs? In other words, you know, how you'll have on a CD. You might have, you know, first track, second track, third track, fourth track. Do they mention anything about the order?
Nope.
They don't mention anything about the order. They're just saying 9 songs. Well, actually, it's 9 albums. If it were songs, you know, you might be able to get in your head and think, well, these could be ordered, couldn't they? But no, that's not what they're doing here. They're just going to take 13 albums, pick any 9 of them, and release those in one set.
So we're going to do a combination.
So that's combinations.
Okay. The word is tricky. That's what we got to look out for. I got to look out for it.
All right. So we're doing 13. P. And we're going to do 9. Woo! Is that right? Something happened.
Mm-hmm.
Picking 9. Oh, I got combinations. What about that? Y'all got to watch me here. Because I was looking for a smaller number because of the fact that it's combination. So there we go. 715 different albums or different box sets. What's up, Felicia?
So we'll make a list of things. That when we know it's permutation. The order matters. When it don't ask for a list of things, give no information about.
Yeah, if there's no distinction, let me kind of put that out. Put that on here. Now, what I would say here, distinction And I put here too, order. That's the same thing. So you can kind of look at it in a couple of different ways.
Okay.
But let's say if we could turn this into a permutations. I don't know how I could do it right offhand. Let me find something else to show you. We got a few more minutes.
Oh, you can put, you gotta release album 1, 2, and 3. If you did that, then it'll be ordered. Cause they want to release them in the top 10, like, in order.
Yeah, maybe you could say like for re-release or something like that.
Yeah.
We're gonna re-release some of them. Let's see if we can find a nice little thing to.
First is commutation.
I don't really like that. I'm not sure what they mean here, but see, order matters, order doesn't matter. I was trying to find a different way to look at it. Here's another way of looking at it here. Arranging people, digits, like passwords, numbers, alphabets, letters, because those things are important when you're talking about order, because a password can't go in any order. If your password is 231, then 123 doesn't work. 213 doesn't work. It's got to be put in order. So,
oh, hold on. Let me take a picture that I can study that.
okay.
Thank you. Thank you. That helps.
See, like for example, on this one right here, they're showing you can arrange. If you got A, B, C, D, 4 to choose from, and you pick 2, then there's all these different 12 different ways of looking at it. But if the order isn't important, then you only got half of that amount, because AB is the same as BA. BC is the same as CB. AC is the same as CA. So that's what we mean by no order. It's where the order that we pull them out doesn't matter. All right, so I think there's something else I could show you to give us a few more minutes here. But in general, there's always going to be more permutations than combinations, because when you're ordering them, there'll be more ways that you can order them. And if you just got the bag, and again, it goes back to the idea of a lottery. A lottery is based upon combinations, because the order does not matter when you're talking about the order of the numbers that they pick. Because usually, I haven't watched that in a long time, but usually they used to do it on TV where they would pull the numbers out, have a thing like a big popcorn machine, and they pull 4 of them out, 5 of them out at random. And if you got those 5 numbers, you win the pick 5. But you don't have to get them in the order in which they pick them. As a matter of fact, that would be a lot harder to do. And so a lot less people would win. Now, I guess in theory, they could change to that at some point. But for it stands now, it's combinations. All right. So we're probably just about. All right. Anybody got any questions? Apologize for messing that up on that thing.
So you're gonna take care of that valuation?
Yeah, I'm gonna do that right now. So I'll see y'all back in a few minutes, all right?
All right, I can't believe
On the other channel.
Okay.
What about valuation too? What happened?
Oh, I told you, I pulled everything out and I'm putting everything back in. So it
Okay.
takes time.
All right. All right.
They don't disappear. They're still in Alex. They didn't walk off, believe me. Okay?
Like none of the information, like I did the information on the valuation of probabilities. Like I never saw that. Like I got a flat G, I didn't get none of them right. And it was valuation.
Right, I know. That's for next week. So don't worry about it.
And
Like I said, I'll
valuation
fix
two,
it.
I didn't even take at all.
You didn't?
It ain't there. Like I had took it, but it
Oh,
ain't.
well, like I said, it's in Alex. Like I said, it's just over in Canvas. I'm redoing all the grades, okay? Making sure everything is right.
I don't even see it in Alex, and I've done it.
Go to Alex. They're over there because I went over there and looked because after you mentioned that. Okay?
Let's see. All right. What time is to go ahead and take the break?
Yeah, let's take a break and I'll see you back in a few minutes.
All right. Don't see it. I know I did it.
Yeah, I think you did.
Yeah, I got a 50 on two. And you say you're gonna take care of three for this next one. All right.